Do you want to understand the most important feature in Git in which you will use in daily basis? Do you want to understand what is Git branching and what is Git merge and what kind of merges that you can do in Git? Do you want to understand what's really happening under the hood when you do a Git commit? If one of your colleagues asked you to do a Git rebase or to rebase your work into another branch and you don't really understand what does it mean, if you want to understand all of these concepts, then you are in the right place, because today we are going to talk about all of these concepts in this episode. So let's get started. To understand the concept of branch in Git, we need to take one step backward and see what is happening when you do a normal Git commit. Git is a key value data store system. What does it mean? It means that for each content you insert in the database of Git, there is a key attached to that content. And by this key, you can get this content each time. This key is generated by a hashing algorithm called SHA-1, Secure Hashing Algorithm. So for each content you insert in Git database, there is a key attached to this content. Each time you insert this key, you will get this content. Before we take an example, we need to understand two important concepts in Git, which is plop and tree. Let's talk in details about the plop object. The plop is a representation of the file in Git, meaning that each file is represented in Git by a plop object. And when we do a staging to the file, like when we say git add that file to Git, Git creates this plop object. And it looks like this. So the plop object has a hash key, contains the size of that file and that version of that file. This is the plop object. Now, let's talk about the tree object. The tree object contains a list of pointers to plops. What does it mean? It means that each tree object points to group of plops inside it. So this tree object, for example, points to this plop and this plop. So basically, the tree object contains a list of pointers to plops, and this tree object points to these plops. Tree is the directory in Git. It's a folder, right? It's a folder containing some files. And the plop is the file. So the file in the Git language is called plop, and the directory in the Git language is called tree. Imagine the tree object is like a directory, and inside that directory there is some files. These files are the plop object, and the directory itself is the tree object. And that tree object contains a list of files or a list of plops inside it. The tree object looks like this. It has its hash, and it has the size of the tree, and of course the list of plops inside it. This is the tree object. Let's talk about the commit object. The commit object points to the tree object, meaning that each commit object points to the tree object. And when you do a get commit, meaning that when you say get commit and you add the commit message, when you finish the commit, on that moment, Git creates the commit object. And this commit object looks like this. It has the hash, it has the size of this commit object, and it has the tree that this commit object points to, and also it contains the metadata for this commit object, like the author or the committer or the message or the date of this commit or the parent of this commit object. So this is the commit object. So basically each plop object is like this, is referenced by the tree object. So the tree object points to plops inside it, and this tree object is pointed by the commit object. The commit object points to the tree object. So commit object points to tree object, and the tree object points to the plops inside it. The plops represents the file in Git. This is the commit object and the tree object and the plop object. And inside it, we will create a new Git repository. If we open the demo project, we will see nothing. But if we show the hidden files by hitting Command-Shift dot, we will see the .git subdirectory. We are interested in the objects subdirectory because here we can see all the trees and plops objects for this Git repository. Right now, there is no plop or trees objects here because we did not add anything to this project. But if we added a file there, let's see hello world file with this content, we'll see the file is created, but Git knows nothing about this file. And if we go to the objects subdirectory, we will see nothing. There is no plop object representing this content because we did not add it. Okay, let's try the low level way first. Let's try this command, git hash dash object dash w and then hello world file. What this command will do, it will insert this content into the Git database, creating a hash key representing this content. As we said before, Git is a key value data store, meaning for each content, like hello world for example, there is a unique key to get this content anytime. When we hit this command, we are expecting here to see a plop object representing this content. And this is what we see. Okay, this is the hash or the key for this content that's stored in Git database. And as we see here, this is the plop object starting with the first two characters of the hash, 3b, and inside it, the file that represent the plop object, which consists of the remaining 38 characters. Now we saw how to create a plop object the low level way. Let's see also how to create a tree object the low level way. We will say git write tree. By hitting this command, we will create a tree object. So we are expecting to see a tree object after running this command. Let's see. Exactly the same way, this is the tree object, starts with the first two characters, and inside it, the remaining 38 characters that represent the tree object. Now we saw how to create a plop object and the tree object the low level way. Now let's delete these two files and try the user-friendly way the Git do it. So right now we have the hello world file. It's not staged, it's in the working directory area. We want to stage it, so we will say git add hello world.txt, and after this command the plop object will be created. So we are expecting here to see the same object because it's the same content that we created before, because we are using the same algorithm, which is SHA-1. So right now, what we will get, we will see here a plop object. And exactly, this is the plop object that represent this content. Okay, let's commit this right now. When we hit commit, what we will see, git commit will do two things. First, it will create the tree object. So we are expecting here to see a tree object, and the plop object will point to this tree object because it's part of this commit or it's part of this snapshot. So we are expecting here to see a tree object, and also we are expecting to see a commit object that the tree object will point to. So we are expecting here to see a tree object and a commit object. Let's run the command. Exactly. So this is the tree object that the plop object points to, and this is the commit object that the tree object points to. So this is the low-level way and the user-friendly way to add plop object, tree object, and commit object. Each time you commit something, the current branch will point to it. So here we created a C1, this commit, and the default branch or the current branch is pointing to it. The default branch that we will get from the system is called master. Then, for example, you made some changes, you staged it, and then you created another commit. This new commit will point to the previous commit, and the current branch will evolve and will point to this new commit. The same thing, we create new commit, it points to the previous commit, and the current branch evolves to point to that new commit. So the branch is simply a pointer. It's a pointer to a commit. By default, you will get a default branch called master when you create a new Git repository. The same as when you clone a repository from any place, you will get a default remote called origin. So the default branch also it's called master. Of course, you can rename this branch to a different name, but this is the default name you will get from the Git system. Each time you do a new commit, this branch is evolving or advancing one step to point to this change. So whenever you do a new commit, always the branch is taking one step forward to point to this commit. When you do several commits, each commit points to the previous commit. So basically, each time you build a new feature or you fix issue, the timelines goes like this, and each commit has a parent that knows what is the previous commit. As you see here, the parent. And this parent can be one commit or more than one commit if it's merge. As you see here, this is the parent and it points to the previous commit. So this is the first snapshot, second snapshot, and this is the last snapshot. Create new branch. We can create a new branch by running the command get commit -b and then the new branch name. So this is the current state or the current history. The last commit is C3 and the current branch, which is called master, is pointing to the last commit, which is C3. When we run the command get commit -b and then we add a name called feature A, this will create a new branch, and this new branch is called feature A, and it's pointing to the last commit, which is C3. For example, if we created another commit called C4, so this new commit will point to the previous commit, which is C3, and the current branch, which is feature A, will point to this new commit C4. Notice how the master or the previous branch is still pointing to the old commit, which is C3, and the current branch is evolving with time and pointing to the last commit, which is C4. Okay, this was the first part of Git branching that you have to know to understand the following concepts, like merge and rebase, which will be the topic for the next episode. Thank you for watching.